Hi, my name is Christie Jones. I'm the Director of Marketing and Vice President at Spirol. So today we're looking at a manual heat inserter and a fully automatic heat inserter for threaded inserts for plastics. These both work by heat, transferring heat to the insert and to the plastic assembly. The main differences between the two: this is a manual machine where the operator would manually load the insert into the plastic assembly. Jennifer's going to pull this down. We have a heated tip that touches a cool insert. It's transferring the heat from the tip to the insert until it's fully installed. So this machine is equipped with an internal air spring. So you'll notice when Jennifer comes down, makes contact with the insert, there's a dwell of a couple of seconds while the heat is transferring from the heated tip to the insert. So we're going to show you one more time again. Again, the operator would manually place the insert and the assembly. So she's going to come down all the way. It's dwelling. Now it's transferring heat, and the insert is being slowly installed until it's at the exact depth. And by the way, the exact depth is made by these micrometer adjustments. So it's a mechanical stop. When you hit full installation, you can't go any further. So we're going to demonstrate installing threaded inserts for plastics using an automatic heat machine. So inside this vibratory bowl is a bunch of inserts that are singulated and oriented in this bowl. They come out of the feed tube, and they're actually preheated to temperature in this chamber section of the machine here. So what Jennifer is going to demonstrate is how easy and quick it is to install the inserts into this plastic half of a yo-yo puck. So the insert's going to go into the hole. Because the insert is already at temperature, it's almost instantaneous. So Jennifer from Machine Design, please step up. She's going to use these dual opto touch sensors. Come back out. All right, and you're good. And the insert is installed to the correct temperature. And we've achieved maximum performance of the insert in the plastic assembly because we've achieved optimum melt and fill within all of the external features of the insert. This is what keeps it in the assembly, by melting into these undercuts and in between the knurls.